Limiting Reactants by John, Christian, and Landon. What is a limiting reactant? A limiting reactant is a reactant in a chemical equation that limits how much product can be formed. Limiting reactants often correspond in problems involving an excess reactant, known as a reactant not completely used up during a chemical equation. Think about it like this. A cheeseburger is made up of buns, cheese, and a patty. Each cheeseburger needs 2 buns, 1 slice of cheese, and 1 patty. For the following example, find how many cheeseburgers can be made and what is the limiting object. If you have 7 buns, 2 slices of cheese, and 4 patties. 2 cheeseburgers can be made because you need 1 slice of cheese for each burger and you only have 2. Cheese is the limiting object, and the buns and the patties are the excess objects. When will you see this? There are 3 main types of problems involving limiting reactants: the identity of the LR, amount of ER left, and the amount of product formed.
To start out our physical example, we found the mass of sodium hydroxide. Then we found the mass of copper 2 sulfate. After that, we ground the copper 2 sulfate into powder. Then we poured water, 100 milliliters of water, into beakers. Right here, John is pouring the water. We poured it into 2 different beakers. After that, we ground up the sodium hydroxide into a powder, just like we did the copper 2 sulfate. Just to see how much mass we lost, we remassed the sodium hydroxide, and we also remassed the copper 2 sulfate. Then we poured the copper 2 sulfate into one of the beakers, and then poured the sodium hydroxide into the other beaker. Then we stirred both of the solutions until it was completely dissolved. Right here you can see us start to stir the solutions. Then we poured the sodium hydroxide into the copper 2 sulfate, and as you can see, it made a lot of precipitate, and it looked kind of disgusting. Then we stirred the solution, which was kind of hard to do because there was a lot of precipitate in there. Then we masked the filter paper that we were going to filter the solution through, and we sprayed water on the filter paper to make it stick to the funnel so that it was easier to pour the solution, like we're doing right here, into the funnel to filter all the liquid out to get the precipitate that we will later use to mass. To end our experiment, we found the mass of the dried precipitate, and we had to split it up into 2 filters.
For example, a 2-gram sample of ammonia is mixed with a 4-gram sample of oxygen. Find the LR, amount of ER left, and the amount of product. First, you balance the equation. Then you find the limiting reactant by seeing how much product is made by each reactant. You use 2 grams of NH3 convert that to moles, and then to moles of NO, back to grams of NO, which comes out to be 3.53 grams. Then you convert 4 grams of O2 into moles of O2 to moles of NO to grams of NO, which comes out to be 3, which tells you that the oxygen is the limiting reactant. To find the excess reactant, you convert from 4 grams of O2 into moles of O2, then to moles of NH3 to grams of NH3, which gives you 1.7. You then subtract the original mass of the NH3 to the mass of the NH3 using the limiting reactant, and you get 0.3 grams of NH3 remaining.
Example 2. What amount of limiting reactant, excess reactant, and product will be created if 35.6 grams of NaOH reacts with 30.8 grams of H3PO4? To start out, you write the balance equation for NaOH reacting with H3PO4. Then you take the 30.8 grams of H3PO4, convert that into moles, and then that number into moles of Na3PO4, and then that into grams, which comes out to be 51.52 grams of Na3PO4. Then you use 35.6 grams of NaOH and convert that into moles using the molar mass, and then you convert that into moles of Na3PO4, converting that again into grams, which turns out to be 48.64 grams. To find the excess reactant, first you use 35.6 grams of NaOH, then you convert that into moles using the molar mass, then you convert it into moles of H3PO4 using the conversion factor in the equation. Then you convert that into grams of H3PO4 using again the molar mass, and you get 29.07 grams of Na3PO4. Then using the starting mass of H3PO4, you subtract 30.8 minus 29.07 to get 1.73 grams of excess reactant.
What mass of carbon dioxide forms in a reaction of 25 grams of glucose to 40 grams of oxygen? First off, the thing you want to do with this problem is balance out the equation. We're going to go ahead and give you the balanced equation now. Next, we're going to convert everything into moles so you can better see the information and use it to solve the problem. Now we're going to give you the information that limiting reactant is the 0.1388 moles of glucose. And next we're going to use the amount of moles that we have that was given to be the limiting reactant and convert it into the amount of CO2 that we could possibly create with this amount of limiting reactant, which ends up being 0.8328 moles. of product. Now we're going to show you the total amount of excess reactant that can be made, or that is made. Using the limiting reactant, we can calculate the amount of excess reactant that is made by using the molar ratio from the problem.
We're on your first year, and I already still confusing myself.
And as you can see from the stoichiometry, the total amount of excess reactant that can be made in this certain equation is 0.8328 moles of O2. But now, after knowing the total that is actually made, we have to subtract that from the total we had to find this amount that's actually left of the excess reactant. And there you have it, 4.172 moles of excess reactant left.